Thank you all for joining us today. I'm Lydia Nisita, and I lead the U.S. logistics vertical at FlowXAI. With me today is Gasper, who leads our logistics vertical in Europe.
Today, we'll be reviewing how logistic organizations can leverage AI to see exceptions earlier, buy better, and adapt faster. Let's begin with situations that will be familiar to almost anyone working in freight operations. A carrier rejects a tender, a departure is missed, a tracking update does not arrive when expected. A customer sends an email asking where the shipment is. None of these events is especially unusual on its own. The problem is what happens between the first signal and the moment the organization responds.
The data may already exist somewhere in a TMS, a carrier portal, an email, a tracking provider, a rate feed, or a spreadsheet, but the right person may not see it immediately. Even when they do, they still need to understand what it means, how serious it is, what alternatives are available, and what action should be taken. That is the gap that we want to discuss today, the gap between visibility and action.
And that gap is becoming more expensive. In July 2026, North American truckload capacity was tightening, spot rates were rising, and route guide performance was weakening. Diesel has softened from recent peaks but remained above year earlier levels, with further volatility still possible. Under those conditions, decisions made using yesterday's assumptions become outdated very quickly.
So the question isn't simply whether your organization has data. The question is, how quickly can you turn a change in the market or the operation into the right decision and the right action? Where does your organization lose the most time or margin today?
We would like to start by understanding where this problem shows up most clearly for you. Take a moment to answer the poll on screen.
Each answer points to a different workflow, but the underlying issue is often the same. There is too much manual work between receiving information, interpreting it, deciding what to do, and carrying out the decision. During this conversation, we will look at how AI agents can help close that gap without asking an operations team to abandon the systems and processes it already relies on. Whichever answer you selected, keep that workflow in mind. Later, we will give you a simple way to assess whether it's a strong candidate for AI.
When people hear AI in logistics, the conversation often jumps immediately to autonomous trucks, predictive models, or customer facing chatbots. Those areas matter, but they can distract from the more immediate opportunities.
The immediate opportunity is inside the decisions logistics teams make hundreds or thousands of times every day. Is the shipment still on plan? Which exception requires attention first? What should we quote? Which carrier represents the best value? Is the operating plan still healthy? Should we intervene now or continue monitoring? What should we tell the customer? AI becomes valuable when it helps answer those questions using the full operational context and then helps move the workflow forward.
That brings us back to the three themes for today: see earlier, buy better, adapt faster. We'll also talk about the other use cases we see across 3PLs and brokerages where AI commonly fails and how to make the internal case for investing in it.
AI is already changing the competitive landscape. The companies with the strongest customer relationships, operational knowledge, and proprietary data only will keep their advantage if they can combine those assets with effective technology execution. Tech also allows people who may be the underdogs now to rise to the occasion.
Let's start with visibility. Most logistics organizations would probably say they already have some form of shipment visibility, but why is that not enough?
Because conventional visibility is often just descriptive. It tells you that a shipment is at a particular location, that an ETA has changed, or that a milestone has not been recorded. Ops teams still have to answer the hard questions. Is the deviation significant? Is it likely to become a service failure? What caused it? Which customer or commitment is affected? And what alternatives are available? A dashboard displays information. An operational AI agent interprets that information in the context of the wider plan.
Before we look at how the operational response works, let's see when teams are typically becoming aware that a shipment is genuinely at risk.
When do you typically learn that a shipment is at serious risk?
Take a moment to answer the poll on the screen.
The important distinction here isn't simply whether the shipment is visible. It is how much usable intervention time is given to your team. If the customer is the first person to flag the issue, or the commitment has already been missed, the operation is still reacting, even if the underlying data existed earlier.
So this is not just alerts anymore.
Exactly. More alerts can make the problem worse sometimes. A useful exception management stack should perform several distinct jobs. It should monitor shipment events and compare them with the expected operating plan. It should detect a meaningful deviation rather than every minor change. It should determine the likely cause and business impact, prioritize the exception based on service risk, customer importance, financial exposure, and time remaining, recommend an action or initiate a governed resolution workflow, and prepare the appropriate communication for the customer, carrier, or internal team. FlowXAI's exception management model follows this pattern, detecting deviations, analyzing causes, classifying severity, recommending corrective actions, and, where appropriate, initiating a controlled workflow.
Can you give us a concrete example?
Of course I can, Gasper. Imagine a high priority shipment with a committed delivery appointment tomorrow morning. The tracking feed shows that the vehicle has stopped progressing. There is also an unread carrier email mentioning a mechanical issue. A traditional system may display a delayed status. An AI-enabled process can bring the pieces together. It can recognize that the shipment is unlikely to meet its appointment. It can identify the mechanical issue as the probable cause, calculate the remaining recovery window, find alternative capacity or transfer options, rank those alternatives by cost, service probability, and customer commitment, prepare the customer update, and route the proposed intervention to an operator for approval. The operator is not asked to investigate the problem from zero. They are asked to review a pre-prepared course of action.
Which metrics should an operations leader use to judge whether that is working?
Another great question. I would avoid measuring the number of AI alerts alone. You should measure the operating outcome. So that would be things like the time from the first risk signal to detection, time from detection to intervention, percentage of exceptions identified before the customer contacts you, percentage resolved before a service failure, number of manual touches per exception, service recovery cost, on-time performance for shipments that entered an exception state, and customer communication time. The most important metric of all may be intervention lead time. How much usable time did the organization gain before the problem became unavoidable? The key takeaway here is that the goal is not to predict every disruption, it is to give people more time and better options when a disruption inevitably will occur.
When logistics companies talk about using AI to buy better, what exactly are we buying better?
There are really two connected decisions. The first is the buy side decision. They're deciding what they can spend on coverage, which carrier to use for a 3PL or broker. Weighing performance, vetting partners, the list of factors goes on. The second is the sell side decision. What should we quote the customer? How quickly can we respond? What margin should we target? What is the probability of winning? And can we actually execute the load at the price we are offering? Organizations often manage these decisions separately, even though the margin depends on both.
And what is AI adding that a rate engine or a pricing table does not already provide?
So a pricing table is built around predefined logic and available inputs, while an agent stack can assemble a much broader decision context. It can consider current and historical lane rates, fuel indexes, carrier availability, seasonal behavior, shipment characteristics, pickup and delivery constraints, past carrier performance. It can even consider customer-specific requirements, previous quote outcomes, the organization's target margin, of course, and current network commitments. It can then support different roles in the process too. So a market intelligence agent can assemble the latest signals, a rate optimization agent can calculate a recommended buy or sell range, a margin agent can test the commercial outcome, and a quote builder can prepare the customer-ready response. FlowX AI's current smart quoting stacks use this type of separation. Market data or market intelligence agents, optimization agents, and quote building or margin performance agents all working together.
So speed clearly matters. But could faster quoting just mean making bad decisions faster?
It could, which is why the agent should not be given a vague instruction, such as produce the best rate. They need explicit operating constraints like a minimum and target margin, approved data sources, carrier eligibility rules, service performance thresholds, confidence thresholds, escalation conditions, and lanes or customer categories requiring human approval. The agents also explain why they recommended a rate. For example, the recommended sell rate is $2,640. Current market range is $2,450 to $2,600. The premium reflects limited refrigerated capacity, a strict delivery window, and this customer's historical accessorial exposure. That gives the broker something they can evaluate, challenge, or approve.
Which metrics matter here?
Good question, and quote turnaround is really only one of them. A balanced scorecard would also include not only quote response time, but quote to book conversion, gross margin per load, margin variance between quote and execution, percentage of quotes requiring manual rework, carrier acceptance rate, service failures on AI-supported quotes, accuracy of predicted buy cost, and customer and lane level profitability, and it doesn't stop there either. The aim is to not simply issue more quotes, it is to respond faster while improving the consistency of the commercial decision. The key takeaway is this: AI should connect market intelligence, procurement, pricing, and execution, not optimize on one while damaging the other.
Let's move from individual loads and quotes to the broader operating plan. Fuel costs rise, capacity tightens, demand shifts, a carrier reduces availability. What does a plant health agent do in such an environment?
So the easiest way to describe it is as continuous plan versus reality monitoring. Most operating plans are based on assumptions about volume, capacity, fuel costs, rates, service commitments, utilization, and more. The problem is that those assumptions don't remain true for the entire planning period. A plant health agent continually asks, are the assumptions supporting this plan still valid? And if not, what is the operational or financial impact?
So it is not simply generating another forecast.
No, so a forecast predicts what may happen. Plan health connects a change to a specific plan and recommends an intervention. For example, fuel increases make a set of lanes structurally unprofitable. Or maybe tender rejection rates indicate that planned capacity will not be available. Or a customer's volume is running significantly above forecast. A carrier is technically meeting the contract but producing repeated service exceptions. Maybe spot market dependence is increasing beyond an approved threshold. A network plan is creating avoidable empty miles or imbalanced capacity. The agent should identify the deteriorating assumption, calculate the exposure, and recommend options.
How should people think about fuel in particular?
Great question and very relevant today, too. Fuel is useful because it demonstrates why a static plan is not enough. A fuel increase does not affect every load equally. The impact depends on distance, equipment, mode, contract terms, surcharge structure, carrier mix, and the organization's ability to pass the increase through. The valuable question is not, did fuel rise? It is, which commitments, lanes, customers, and future quotes are now exposed, and what action should we take? That is where AI can turn a market change into a prioritized operating response.
And what should be measured?
Another great question. Useful plan health measures include forecast versus actual margin, contracted versus spot capacity exposure, tender rejection trends, cost change not passed through to customers yet, empty mile or utilization variance, and more. A successful plan health agent should help the org act while options are still available. Key takeaway here is that the objective is not a perfect plan. It is a plan that recognizes when it is becoming wrong.
So we have focused on three areas: But those are not the only opportunities. Where else do you see strong use cases?
All over, and I know you do too over in Europe. So we generally look for workflows with four characteristics. One is high transaction volume, another is repetitive interpretation or coordination work. The third is decisions distributed across several systems. And fourth, a measurable cost, service, margin, or risk outcome. Using those criteria, the most relevant opportunities include the following. Exception management, so detecting deviations, assessing severity, identifying root causes, recommending or initiating resolutions, with a business outcome of fewer service failures and escalations. Another is smart quoting, so assembling market data, recommending buy and sell rates, protecting margin, and generating customer-ready quotes with the goal of faster response and better pricing consistency. Load entry, so extracting shipment data from emails, docs, portals, and EDI, validating and syncing with the TMS. My logistics people know that sometimes even if loads are coming in, they may not be fully complete, so AI can help there. And the business outcome for this one is less manual entry and fewer data errors. Carrier matching and tendering, so comparing cost, availability, service history, and contract compliance, leading to better capacity decisions. Plan health and network optimization, like we were referring to before, monitoring capacity, utilization, cost, and service assumptions, leading to faster adaptation to changing conditions. Invoice reconciliation, we do back office too, matching invoices with rates, tenders, PODs, contracts, and accessorials, leading to less leakage, fewer disputes, faster settlement. Customs validation, cross-checking filings, invoices, bookings, declarations, and shipment documents, leading to fewer documentation and compliance exceptions. Customer service, answering routine status questions, generating updates, escalating complex issues, obviously leading to faster response and lower support effort and downstream customer experience impacts. Inbox and communication management, and performance and margin intelligence. Performance and margin intelligence, somewhat similar to the quoting workflow we were discussing, analyzing quote outcomes, carrier performance, customer profitability, and operational patterns, leading to better commercial and operating decisions strategically across an org. FlowXAI's current logistics portfolio that Gasper and I manage along with a wonderful team covers these categories across brokers, 3PLs, carriers, forwarders, shippers, even retailers, including exception management, smart quoting, load entry, invoice reconciliation, customs validation, procurement, customer service, and network optimization.
So, what you're saying is the key is not to deploy all of them at once.
I definitely wouldn't recommend that anyone deploys the long list I just read all at once. Good point, Gasper. Exactly. We start with a workflow where the pain is visible, the owner is clear, and the result can be measured. That way we prove very quick value to each other, and then we have a long road of build from there.
And this brings us to the important part of the conversation, which is where does AI go wrong in logistics?
That's a great question, and the need for AI is so pertinent right now, and there's so much interest that, of course, you have companies popping up left and right, people offering to solve that problem for logistics org. So, how do you really separate the real from the noise? So, thank you for asking that question, Gasper. And there are several recurring failure patterns that we see in AI developments across the industry. For one, a chatbot is mistaken for operational automation. So, a chatbot obviously can be helpful for answering quick questions, summarizing documents, but it does not understand your core operating process. It doesn't have access to all of your correct systems, doesn't follow escalation rules, or complete a governed action. So, this is something that we talk about a lot, the difference between a Claude or a ChatGPT and actual institutional AI. Secondly, prediction can stop before action. So if an organization predicts delay risk, tender rejection, or capacity shortages, but leaves operators to investigate every case and coordinate the response manually, then the organization has added intelligence without removing the operational bottleneck. And that's the sense of, that's when someone adds AI and it looks really cool and it gives you access to all this additional information, but are you really leveraging it within your organization the way that you need to be so you're not adding costs without seeing ROI? Thirdly, the agent is too broad. So this kind of calls back to Gasper's question before of should we do everything all at once? Definitely not. So if an agent is simply told to manage all of my shipments or optimize logistics, that scope is too ambiguous. It's not going to be able to do anything because it's been prompted to do everything. Fourth one is that the AI is disconnected from operational systems. So similarly to the fallback with chatbots, if you don't have your AI connected to all of your data, it's not going to be able to make informed decisions. FlowXAI is designed to connect AI agents and business processes with existing infrastructure through APIs, SDKs, workflow integrations, and process orchestration, rather than requiring organizations to replace their core systems. Two more failures that we'll discuss now. For one, if there's no control framework, AI deployments can fail in production. AI used in mission critical workflows need approved sources, rule-based access, observable actions, audit trails, confidence thresholds, human approval where required. It will still be important in an industry like logistics, defined exception handling, and safe fallback behavior. Without those controls, the org may produce faster outputs, but create unacceptable commercial or operational risk. And finally, something that we see is if nobody owns the outcome, the AI agent is not going to be deployed successfully. So IT may own the technology, but operations owns service and execution, right? Finance owns the economic case. Commercial teams own pricing and customer commitments. So an AI initiative without a named business owner and a defined KPI will struggle to move beyond experimentation.
So those failure points show that getting AI into production is about much more than just choosing a model. Let's see which obstacle is most significant inside your organization.
Now back to our audience. What is the biggest barrier preventing AI from entering your operational workflows?
Take a moment to answer the poll on screen.
The important point is that these barriers rarely exist in isolation. Accuracy without integration produces an answer that sits outside the operation. Integration without governance creates risk. Governance without a business case creates a technically sound initiative, but nobody funding it. Production AI has to address the operational, technical, and economic requirements all together.
So how is the FlowX AI approach different?
As if you don't know, Gasper, thank you for keeping the conversation going. So we start from specialized operational agents and agent stacks rather than a blank generic assistant. Those agents are integrated into governed business workflows, connect to the systems that the organization already uses, and can be combined with human approval and deterministic business rules. FlowXAI 6 currently provides more than 220 specialized agents across industries, including banking, with logistics suites focused on quoting, load entry, exception management, visibility, and plan health. The objective is not to eliminate customer-specific configuration. It is to avoid starting every use case from zero. The key takeaway here is that the model creates the answer, the production system determines whether the answer can be trusted, controlled, and acted upon.
Even when the use case is compelling, logistics leaders sometimes still have to build support internally. What does each stakeholder need to hear?
Yeah, so building support internally is super key to every engagement that we have, of course, and the same project should be explained differently to operations, IT, and finance. So, what operations teams need to hear is this will reduce fire drills, manual coordination, and repetitive investigation while keeping operators in control. The evidence that you can provide them is some of the things that we'll address in a second here: exception response time, manual touches, quote turnaround, service recovery, workload, etc. An IT team may care more about how it can work with systems, access rules, data, and architecture that they already have. And they want to hear it won't become an unmanaged AI side project. What to bring to them is integration design, the security model, permissions, the audit trail they'll be able to track, monitoring, and fallback paths. Then someone like a CFO will care more about obviously high level goals. So a measurable source of margin leakage, cost to serve, or working capital friction. What we can bring to them is baseline economics, expected value range, implementation cost, payback method, and value tracking.
And in your experience, what is the most credible way to calculate the initial business case?
Good question. And a business case, of course, isn't always going to be 100% accurate. A lot of the times when we implement AI in an organization, the ROI created after manifests also in so many downstream impacts that are really hard to forecast. But what I suggest is first using a narrow workflow and building the estimate from operating facts that we kind of mentioned before, right? So monthly number of quote requests, average handling time, fully loaded costs of the people involved so that their time can be reallocated to more valuable revenue generating work, current error, rework rate, invoice leakage, things of that nature. Don't start with a universal claim about AI productivity. Instead, start with this process handles 18,000 events per month, right? Requires an average of 11 minutes of work and produces this much rework or margin exposure. Then model what happens if AI reduces the effort, improves the decision, or identifies the issue earlier.
And with all that said, what would you recommend as the implementation approach?
So, like we said earlier, start with one or two tightly defined agents, not your whole scope at once. Agree on the KPIs before deployment, prove value in the real workflow, and then expand into adjacent use cases. That gives operations a controlled starting point, IT a manageable scope, and finance evidence rather than a speculative transformation case.
We want to finish with the questions logistics leaders ask us most often when they begin evaluating operational AI. These are the questions that usually determine whether an initiative remains an experiment or becomes a production program. Let's begin with the most obvious objection. We already have a TMS, a tracking tools dashboard, or a visibility provider. What is AI adding?
Great question. So those systems remain essential, of course. AI should not replace the system of record. Its role is to work across those systems and interpret what the combined information means. A visibility platform may show that an ETA moved by 3 hours. The AI enabled workflow determines whether the change threatens a commitment, what caused it, what alternatives exist, etc. The distinction is between displaying a change and coordinating a response. The TMS remains the system of record. The AI agent becomes part of the operating layer that helps people decide and act.
Many logistic organizations know their data is fragmented. Do they need a major data transformation before they can start using AI, or can they just dive in?
I love that question because that's a major misconception that I see quite often. So the answer is no, but the first use case must be selected carefully. You don't need perfect enterprise data. And especially in an industry as complex as logistics, it is a long road to getting there, right? You need enough reliable information to support a specific decision. For exception management, that might include shipment plan and milestones, latest tracking events, carrier communication, etc. For quoting, it might include shipment details, relevant rate sources, carrier history, and more. The agent should also know when required information is missing. That's a really key piece, right? A safe output may be I cannot produce a quote within the approved confidence threshold because equipment availability has not been confirmed. An agent that can recognize and admit to that is much safer than an agent that's going to provide a quote that isn't totally backed up with all the important information. So that's better than inventing certainty, of course. A narrow use case can also expose where data quality is genuinely preventing better execution, giving the organization a much more focused improvement plan. So, oftentimes, I'll deal with logistics leaders who have this amazing vision, right? Amazing long term vision of all the projects they want to get done. But what I often encourage them to do is understand that after the first use case is in play, that may change the way that you're thinking about your long term development.
So, this is probably the commercial team's biggest concern. How do you prevent AI from making an expensive recommendation or an expensive mistake?
Great question. So, first, you don't treat that model as the entire decision system. It operates inside a controlled process containing approved data sources, your legacy systems, pricing and margin rules, for example, carrier eligibility, customer specific requirements, etc. Secondly, you separate the responsibilities. So one agent gathers market intelligence, another recommends a price, another validates margin feasibility. The workflow can compare their outputs before anything reaches the customer. Third, you keep humans in control for higher risk decisions. For example, quotes within an approved range may be generated automatically. Quotes below a margin threshold require commercial approval. Unusual equipment, high value freight, or low confidence capacity requires manual review. Finally, record the reasoning and inputs used so that decisions can be reviewed and improved.
Is the end goal to remove people from these workflows?
So the immediate objective is to remove avoidable work from people, not expertise from the operation. Experienced logistics professionals spend too much time, in my opinion, searching several systems, copying shipment data, reading repetitive emails, comparing rate sheets, investigating obvious exceptions, preparing routine customer updates, and reconciling records. Those activities consume attention but do not necessarily require the full judgment of an experienced broker or operator. AI should prepare the context, handle repetitive steps, and surface the cases that genuinely do require judgment, negotiation, or customer management. In that model, people handle fewer low value touches and have more time for difficult exceptions, strategic carrier relationships, customer decisions, and commercial growth.
AI business cases can become very vague very quickly. How do we keep this credible for finance?
So we begin with the economics of the current workflow, like we've discussed, how many exceptions occur, how many quote requests are received, those types of things. And then we measure the same variables after deployment. That's a key piece of it as well. So the CFO doesn't need to believe that AI will transform logistics, right? They need evidence that a defined workflow can generate a measurable economic improvement. And that's also why you'll see a lot of vendors offer a pilot period, right? You may forecast the ROI a certain way, but measuring the KPIs is what's going to actually see how it's working in action.
What questions should the businesses be prepared to answer when IT joins the conversation?
So IT will typically want clarity on at least these areas, right? So which systems and data the agents access, how authentication and permissions are enforced, where the models and data are hosted, what is logged and auditable, how errors and low confidence outputs are handled, how the workflow behaves when a connected system is unavailable, and how the agents will be monitored and updated. So the business should welcome those questions, of course. They're really important questions to understand, is this deployment going to succeed or fail within my current tech stack? Operational AI only becomes really available when it is integrated into the real environment and managed as part of that environment. FlowX AI is designed for this model. Agents can be triggered through business workflows, APIs, and application integrations with outputs stored, displayed, or used to continue a process.
Back to our audience now. We've covered the operational opportunity, the technology requirements, and the business case. So let's make this practical. If you were choosing a first workflow today, where would you begin? Take a moment to answer the poll on screen.
There's no universally correct answer here, of course. The right starting point depends less on which use case sounds most impressive and more on where the business problem is frequent, measurable, and clearly owned. Which brings us to the final question.
Let's finish with a practical question. If an organization sees opportunities in quoting, exceptions, load entry, invoicing, and planning, where should it start?
Choose the workflow that scores highest across 5 criteria. The problem occurs frequently, the current cost or impact can be measured, one business leader clearly owns the outcome, the agent can access the minimum required information, and the result can be observed within weeks rather than years. Don't begin with AI across the enterprise, rather begin with, we want to identify high-risk shipment exceptions at least 2 hours earlier and reduce manual investigation time by 40%. Or another example could be, we want to respond to standard quote requests in minutes while maintaining an approved margin range. These are things that I hear all the time. That creates a defined business case, a manageable technical scope, and a clear test of value. Once it works, you can extend the same operating foundation into adjacent workflows.
We have covered a wide range of opportunities today. but they all come back to the same idea.
Absolutely. Logistics organizations do not need more disconnected information, we all know. They need a faster and more reliable path from signal to decision to action. That may mean identifying an exception earlier, producing a better quote, recognizing an unhealthy plan, reconciling an invoice, or preparing the next best action for an operator.
The strongest AI use cases are not necessarily the most futuristic ones. They are the workflows where teams already know they are losing time, margin, or service quality, and where better decisions could produce visible value.
So don't begin by asking, where can we use AI? Begin by asking which operational decision is currently too slow, too manual, too inconsistent, too costly, or discovered too late.
Choose one of those decisions, define the outcome, establish the controls, connect it to the real workflow, and measure what changes. This is how AI moves from a promising demonstration into a production capability.